Welcome to another AE Spy video. Today, we will talk about invariance, this magical concept that appears in many different areas of mathematics, yet not many people are used to thinking about. So, what's an invariant? An invariant is simply something that doesn't change. More formally, it's any property of an object that remains unchanged under certain transformations. Invariants are incredibly powerful. In a system full of moving parts, identifying an invariant allows you to focus on what stays constant and avoid being overwhelmed by the changes. To see how powerful spotting an invariant can be, we will look at some interesting examples. This video will be split into two parts. In the first part, we will cover two nice examples with solutions. Then, we will give you three examples to think about, as solving problems is the best way to improve. Also, feel free to leave your answers in the comments. In the next part, we will discuss the solutions to those three examples and add some notes on invariants. In the following 2 by 2 grid, with one blue square and three white squares, we are allowed to make certain moves. In each move, we pick a row or a column and flip its colors. Blue becomes white and white becomes blue. The question is, can we make the entire grid white using these moves? Well, after trying a little, you might start to become convinced that you can't. But can you explain why? Let's think this through. What are the possible moves we can make? There are three possibilities. Either we select a row or a column with both white squares, both blue squares, or one white and one blue square. In the first case, the number of white squares will decrease by 2, and the number of blue squares will increase by 2. In the second case, the opposite happens, and in the third case, the number of squares of each color doesn't change. Now, since the number of blue squares either doesn't change or changes by 2, the parity of the number of blue squares is an invariant. And with that, we're pretty much done. We started with one blue square and want to end with 0. But our moves don't change the parity. Hence, it's impossible. Given the following triangle, you are allowed to make the following move. Pick any vertex and move it parallel to the opposite side, as you can see on the screen. The question is, can you transform it into this other green triangle using a sequence of this move? Let's try this together. We can make these nice moves maybe to get the first vertex in the correct position. Same with the second vertex. But then we are stuck. No matter how we move the third vertex, it'll never land on the right position. Well, maybe there was another set of moves that would have worked. How can we know? Once again, we want to look for an invariant. And here, it's actually pretty obvious what it could be. You guessed it right, the area of the triangle. The area doesn't change after each move. To see this, notice that the area is given by half the base times the height, and moving the vertex parallel to the opposite side keeps the height the same, and the base remains the same as well, as it is just the opposite side. Now, since the two triangles have different areas, it is impossible to transform one into the other using these moves. You have the three numbers 8, 11, and 23 on the board. Each step, you are allowed to subtract 1 from one of the numbers and write the product of the other two on a paper. You keep making steps until one of the numbers on the board becomes 0. Only then you will add all the numbers in your paper and this will be your sum. The question is, what are all the possible sums you can get? And don't forget to leave your answers in the comments. You have 15 red balls, 10 blue balls, and 8 green balls. You are allowed to make the following moves. Either take two balls from the same color and replace them with one of each of the other two colors, or you can do the reverse. That is, take two balls of different colors and replace them with two of the third color. The question is, can you make the number of red, blue, and green balls the same? Again, don't forget to leave your answers in the comments. You have the following 5 by 5 grid with 4 infected squares. Two squares are said to be adjacent if they share an edge. In each step, a square with at least two adjacent infected squares becomes infected. Steps continue to occur until no more changes happen. In our example, the following will happen. The question is, can you place the four starting infected squares in such a way that the entire grid becomes infected at the end? And that's it. Don't forget to leave your answers in the comments, and thanks for watching.